In this video, we'll write the balanced net ionic equation for CaBr2 plus Na3PO4, calcium bromide plus sodium phosphate. The first thing we do with net ionic equations, we write the molecular equation. This is the molecular equation. I think I'll balance the phosphates first. I have one here, and then I have two here. So two phosphates, that means I'll put a 2 in front of the sodium phosphate. Those are balanced. Now I have 2 times 3, 6 sodium atoms. Put a 6 here. Gives me 6 sodium atoms, but I have 6 bromine atoms. So I'll put a 3 here. Those are balanced. 3 calciums, and I have 3 calciums here. This is the balanced molecular equation. Now we can write the states for each substance. If you know your solubility rules, compounds with bromine, they're usually soluble, and then compounds with group 1 elements like sodium, they're almost always soluble. Phosphates in general are insoluble, but it's with this group 1 element, sodium. So this is going to be aqueous. Here we have a phosphate, though, with calcium. That's in group 2. So this is going to be insoluble. If we put an S, because it's a solid, it won't dissolve in water. These substances react. They make this solid. It falls to the bottom of the test tube as a precipitate. So we have Ca3PO4 calcium phosphate. That's going to be a precipitate in this net ionic equation. Sodium compounds, again, in compounds with bromine, very soluble. Put an AQ after that. Now we can split the strong electrolytes into their ions for the complete ionic equation. Calcium group 2, that's going to be 2 plus. And the bromide here, that's 1 minus, each one of them. So I have 3 calcium ions, Ca2 plus, and I'll write the states at the end. Let's not do that now. Plus, I have 2 bromide ions times 3. So I have 6 of these bromide ions here. Then sodium's in group 1, that's 1 plus, each one of those, and the phosphate, the whole thing, 3 minus. So 2 times 3, that gives me 6 of these sodium ions, that Na plus, and then I'll have 2 phosphate ions. So these are the reactants in our net ionic equation. For the products, we don't split solids apart, so we're going to keep this Ca3PO4 together since it's a precipitate. And then we said sodium, 1 plus, the bromide ion, 1 minus. 6 sodium ions, just like in the reactants, plus we have 6 bromide ions, just like the reactants. So this is the complete ionic equation. Now we can cross out the spectator ions. They're on both sides of the complete ionic equation. So I look here in the reactants and in the products, I see I have 6 bromide ions right here in the reactants and in the products. Spectator ions, cross them out. I see I have 6 sodium ions here in the reactants, again in the products. These are spectator ions. We cross those out. What's left, that's the net ionic equation for calcium bromide plus sodium phosphate. Let me clean this up. I'll write the states in. We'll have our net ionic equation. So this is the balanced net ionic equation for calcium bromide plus sodium phosphate. You'll note that the atoms, they're all balanced. If you count them up, they're the same on both sides. And the charge is balanced too. 3 times 2 plus, that's 6 plus. 2 times 3 minus is 6 minus. So the 6 plus, 6 minus gives us a net charge of 0 in the reactants. The products, this is a neutral compound, net charge of 0. This is Dr. B with the balanced net ionic equation for CaBr2 plus Na3PO4. Thanks for watching.